So you may want to recognize this. There's a bunch of common polar graphs, and this is one of them. I recognize this as a rose. I'll give you a link to a bunch of the common ones so you can recognize them right off the bat. So I kind of know it's one of these. But we can figure it out, right? So let's just kind of play with it a little bit. Let's say theta was 0. Let's say the axis was 0. Then the angle was 0, so we're just right on the axis. Your angles start at here and go counterclockwise. So if your angle was 0, the radius would be the cosine of 0, and the cosine of 0 is 1. So if we're at 0, the radius should be out at 1. So it's not that one. If we're at 0, the radius should be out at 1. Ooh, that guy's looking good. This guy here could potentially be something. It's got a bunch of possibilities actually though, so that wouldn't work. Same thing here. The radius has to be 1 when x is 0. It can't be anything else. So we can eliminate those that way. Bunches of other ways you can think of it. Remember that your cosine, a normal graph with an x and a y of just y equals cosine of x, looks something like that. And the cosine values are always between positive 1 and negative 1. So the cosine of any angle should be between positive 1 and negative 1. So the radius should be between positive 1 and negative 1. So for any angle, the radius that it can go out can't be any more than 1. So that's why we have it restricted to those two cases based on that idea. Here, when the angle is, whatever the angle is, it could possibly be more than 1. Like this is going off forever. And this could have been really, really big here as well. So you can eliminate some from that. You can play more, like just to kind of give you a better idea of what's going on. What if we threw in a number for that? What if we said r of theta was the cosine of 3 theta? I think that's actually what they had drawn here when n is 3. So if we were to plug in values for theta to figure out what the radius was, I like to put in values that are going to make that pretty. So I would like 3 theta to be things that I know. And I know the cosine of 0. I know the cosine of pi halves. I can do better. I know the cosine of pi fourths. I know the cosine of pi halves. I know the cosine of 3 pi fourths. I know the cosine of pi, etc. So the cosine of 0 is 1. The cosine of pi fourths, if 3 theta is pi fourths, and the cosine of 3 theta is, cosine of pi fourths is root 2 over 2. Cosine of pi halves is 0. Cosine of 3 pi fourths is negative root 2 over 2. Cosine of pi is negative 1. And let's see what we've got. So I've got them all for 3 thetas. Now let's go backwards and actually figure out if 3 theta was 0, just divide by 3 to figure out what your theta is. So 0 divided by 3 is 0. Pi fourths divided by 3 is pi 12ths. Pi halves divided by 3 is pi 6. 3 pi fourths divided by 3 is pi fourths. Pi divided by 3 is pi divided by 3. And so if we were to graph that, let's graph that in the middle. So this one's saying if I go out an angle of 0, I go out a radius of 1. So there. Then if I go out a radius of pi 12ths, I go out, an angle of pi 12ths, I go out a radius of root 2 over 2. Pi 6, if I go out that angle, I'm back at 0. Pi fourths, if I go out this angle, I'm at negative root 2 over 2. So I go this way that amount. And if I'm at pi thirds, I go to a negative 1 down here. So I didn't quite graph enough, but you can kind of see I have this bit going on. It looks really ugly. And yeah. I made a mess of this. But couldn't be that guy. Play with it. You'll like it. Okay, maybe I'll come back.